For thousands of years, we've only seen one face, the near side. It's familiar, covered in dark patches that look like a face. But there's another side, the far side, the side that never faces Earth. We thought it was just more of the same. We were wrong. China just landed a robot on the far side, something no other country has ever done. They drilled into the dirt, scooped up rocks, and brought them back to Earth. And what they found is shocking, evidence of a global ocean of fire, wonder materials that shouldn't exist in nature, and clues that the moon has a completely different history than we thought. The moon isn't just a dead rock, it's a two-faced mystery, and China just peeled off the mask. Let's find out what they saw. Landing on the far side isn't just hard, it's famously impossible. The moon is tidally locked. It spins at the exact same speed it orbits Earth, always showing us the same face. The far side is always blocked. Radio waves travel in straight lines. If you send a robot there, the moon blocks your signal. You can't talk to it. You can't steer it. Radio silence. That's why NASA never went there. Why the Soviet Union never went there. It's a communication dead zone. But China innovated. They launched a satellite called 𝘁𝗂𝗃𝗃 and parked it in a special gravity pocket past the moon called a halo orbit. This satellite acts like a mirror, bouncing signals over the moon's shoulder. With this bridge in place, they launched Chang'e 6. In June 2024, it touched down in the South Pole Aitken Basin, the largest, deepest, and oldest impact crater on the moon. A hole so big, it nearly broke the moon in half billions of years ago, 1,500 miles wide and 5 miles deep. The descent was terrifying. For 15 minutes, the lander was on its own, using AI to dodge boulders and craters in real time. But they stuck the landing. They grabbed the dirt, and 53 days later, a capsule landed in Inner Mongolia with 4 pounds of treasure inside. When scientists opened it, the first thing they noticed was the color. Look at the moon tonight, and you'll see dark spots. We call them Maria, Latin for seas. They aren't water. They're giant oceans of frozen lava. Billions of years ago, volcanoes erupted on the near side and flooded the lowlands with black basalt. But the far side? Almost zero dark spots. It's white, rugged, covered in craters on top of craters. Why did one side melt and the other stay solid? This is the lunar dichotomy, the biggest mystery in lunar science. The Chang'e 6 samples just gave us the answer. It has to do with a radioactive soup called KREEP, potassium, rare earth elements, and phosphorus. This chemical cocktail produces heat. It's radioactive, a planetary electric blanket. Apollo samples from the near side were full of KREEP. They were hot, but Chang'e 6 samples? Clean. Almost no KREEP. This confirms a wild theory. The moon is lopsided on the inside. Billions of years ago, all the radioactive elements concentrated on the near side. They cooked the crust, thinned it out, and allowed volcanoes to erupt for billions of years. The far side, without that heater, froze solid early. It developed a crust, maybe 20 miles thicker, that lava couldn't punch through. While the near side glowed with lava, the far side was a cold, white wasteland. The moon isn't one world, it's two worlds glued together. But the chemistry gets even weirder. Imagine taking a pencil. The lead is graphite, layers of carbon. Now imagine peeling off a single atomic layer with tape. That single layer is graphene. Graphene is a wonder material, 200 times stronger than steel, conducts electricity better than copper, transparent. On Earth, we make it in high-tech labs with lasers and chemicals. It doesn't just happen, or so we thought. Chinese scientists analyzed the Chang'e soil with electron microscopes and found it. Natural graphene, flakes just 2 to 7 atoms thick, sitting in the moon dust. How does a high-tech supermaterial form naturally on a dead rock? The theory is violent. The moon has no atmosphere. It's constantly bombarded by the solar wind and meteorites. When a meteorite hits, it creates insane pressure and heat for a split second. This impact shock compresses carbon molecules instantly, fusing them into perfect hexagonal graphene sheets. The moon is a giant factory, hammering carbon into graphene using asteroid impacts. Why does this matter? If we build a moon base, we don't have to ship materials from Earth. We can harvest them from the dirt. Super strong habitats, conductive wires, electronics. The lunar soil isn't just dirt, it's a resource. Chang'e 6 verified the most violent chapter in the moon's life, the global magma ocean. We think a Mars-sized planet named 𝘱𝗃𝗃 smashed into baby Earth 4.5 billion years ago. The debris formed the moon. If true, the baby moon was so hot it was entirely liquid, a ball of molten rock floating in space. As it cooled, crystals formed. Heavy crystals sank. Light crystals floated to form the crust. This is differentiation. Until now, this was just a model, but Chang'e 6 proves it. The rocks contain minerals like anorthosite that can only form by floating to the top of a magma ocean. This confirms the entire moon was once a single sloshing ocean of lava. The moon isn't a captured asteroid. It's the child of a violent collision made of Earth, melted and reformed in space. But Chang'e 6 didn't just scratch the surface, it touched the soul. Because the South Pole Aitken Basin is 5 miles deep, it punched through the crust and exposed the mantle, the deep rocky interior. On Earth, we've never drilled to the mantle. But on the moon, the impact did the work for us. The samples contain minerals called pyroxene and olivine, heavy green crystals that belong deep underground. Finding them on the surface is like finding gold nuggets on the beach. This gives scientists the first ever direct look at the inside of another world. We aren't just looking at the skin anymore, we're looking at the organs. We're going to hit pause for 1 second. We're talking about a world born in fire, with 2 different faces, covered in natural supermaterials. We're rewriting the history books right now. If you're enjoying this deep dive, smash that subscribe button and turn on notifications. You don't want to miss the next discovery. Now let's get back to the moon, because the most exciting thing China found was something wet. For decades, we were taught the moon is bone dry. Apollo astronauts came back with dust drier than the driest desert, but China's missions shattered that idea. In the Chang'e samples, they found a new mineral, ULM1, a hydrated salt, a crystal with water molecules trapped inside. This isn't ice hiding in a crater, this is water locked in rocks sitting in sunlight. And there could be massive amounts, maybe 270 billion tons globally. Where did it come from? Meteorites. The samples contained fragments of carbonaceous chondrites, rare space rocks rich in water and organic compounds. The moon's been pelted by these water bombs for billions of years. With no wind or rain to wash them away, they're still there, mixed into the soil. This changes everything. If water is everywhere, locked in rocks, we can bake it out anywhere on the surface. The moon isn't a desert, it's a sponge. But the water isn't just in salts, it's in the glass. When meteorites hit, the heat melts rock instantly. Droplets cool mid-air and turn into tiny glass beads. The lunar soil is full of them. Chinese scientists found these beads are filled with water. The solar wind blasts hydrogen at the moon. That hydrogen bonds with oxygen in the glass to form water. The glass acts like a storage tank. China estimates these beads alone could hold enough water to fill Lake Tahoe. And it's easy to extract. Just heat the beads and the water steams out. This is the key to survival. We don't need to bring water from Earth. We just need a vacuum cleaner and a microwave. Water is great for drinking, but there's something else in that soil worth trillions of dollars. Helium-3. Helium-3 is the holy grail of energy, a rare isotope that could power nuclear fusion reactors without radioactive waste. Clean, infinite energy. Earth has almost none. Our magnetic field blocks it, but the moon's been soaking it up from the sun for 4 billion years. The Chinese samples confirmed it. They found a new mineral, Chang'e. Why? A clear columnar crystal. And inside, Helium-3. This is the first new lunar mineral discovered by China and the 6th ever by humanity. But it's the implication that matters. China has explicitly stated they're interested in mining the moon. They aren't just there for science, they're there for resources. Estimates suggest 100 tons of Helium-3 could power Earth for a year. The moon has roughly 1 million tons. That's thousands of years of energy sitting in the dirt. If they can extract Helium-3 efficiently, the moon becomes the Persian Gulf of the 21st century, the most valuable real estate in the solar system. Apollo samples told us the moon's volcanoes died 3 billion years ago, but Chang'e's 5 samples shocked everyone. They were only 2 billion years old. The moon stayed alive 1 billion years longer than we thought. How? Small bodies should cool fast. Chang'e's 6 samples from the far side are older, about 2.8 billion years. The far side cooled first. It died early. The near side, kept warm by KREEP, stayed alive much longer. It paints a picture of a dying world that clung to life on one side. One hemisphere erupting with fire, the other frozen in silence. That was the moon for 1 billion years. So what is China going to do with this knowledge? They aren't just writing papers. They're building a map. China has announced the ILRS, the International Lunar Research Station. They plan to build a permanent base on the South Pole by the 2030s. They know where the water is, where the building materials are, where the energy is. And by landing on the far side, they've proven they can operate in the hardest places. While NASA focuses on sending humans back with Artemis, China is focusing on sustainability. They're figuring out how to live off the land. The far side landing wasn't a stunt. It was a survey. They checked the backyard to see if it was a good place to build. And the answer is yes. China isn't the only one looking at the map. The United States is looking at the same spots. NASA has identified 13 potential landing sites for Artemis 3, and China is targeting almost the exact same craters. Specifically, everyone wants Shackleton Crater. Why? It's at the South Pole. It has ridges with near-constant sunlight for solar power and deep valleys holding massive water ice. It's the prime real estate of the moon, like an oasis in the Sahara. Whoever controls the oasis controls the desert. China plans to launch Chang'e 7 in 2026 and Chang'e 8 in 2028 to survey the South Pole water ice. NASA plans to land astronauts around the same time. We're heading for a celestial traffic jam. Unlike the 1960s, where we planted a flag and left, this time we're building houses. And there are only a few good spots. The discovery of water in glass beads and salts might relieve some pressure. If we can get water anywhere, maybe we don't need Shackleton as badly. But the race is on, and right now, it's neck and neck. The moon is not what we thought it was. For decades, we treated it like a dusty attic. We went there, looked around, and left. But China has dusted off the old books and opened the windows. They found a world of duality, fire and ice, a world coated in wonder materials like graphene and filled with hidden water. They found the far side isn't just a boring twin, it's a completely different geologic animal. And most importantly, they found the moon is useful. It's a factory, a mine, a gas station. The space race is back on. But this time, the finish line isn't a flag, it's a factory. And right now, China has the best samples in the lab. What do you think? Are you excited about mining the moon? Or should we leave it alone? And what about that graphene? Could that be the key to building moon bases? Let us know in the comments. We read every single one. If you enjoyed this trip to the dark side of the moon, subscribe and ring the bell so you don't miss what's coming next. And if you want to keep exploring the cosmos right now, click on the next video I've linked for you up here. Thanks for watching. Keep looking up, and we'll see you in the next one.